Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wasallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wasallam. Ameen. Alhamdulillahi rabbil alameen. The topic of this lecture is sampling and estimation of S2. For this lecture, I am using the work of one of my best students, Miss Laiba Gulzar of class 2021, the Lyceum. An important advice for me and for everyone: be of benefit to others. Applications. We use sampling and estimation to estimate the values of unknown population parameters. The population parameters of binomial distribution are n and p. For Poisson, the parameter is lambda, and mu and sigma square are the parameters of normal distribution. There are two types of estimates. Number one, point estimates, and number two, interval estimates. Interval estimates are commonly known as confidence intervals. Population. In a statistical inquiry, you often need information about a particular group. This particular group is known as the population or the target population. It would be small, large, or even infinite. Note that the word population does not necessarily mean people. Here are some examples of populations: pupils in a class, hospitals in Wales. Surveys. Information is collected by means of a survey. There are two types of surveys: a census, a sample survey. In a census, every member of the population is surveyed. Sample survey. When a survey covers less than 100% of the population, then it is known as a sample survey. Explain briefly what you understand by a population. A population is a particular group of individuals or items. Bias. The purpose of sampling is to gain information about the whole population by selecting a sample from that population. You want the sample to be true representative of the populations. So you must give each member of the population an equal chance of being selected in the sample. This should eliminate any bias in the selection of the sample. So to eliminate all types of bias, you must give every member has an equal chance of being selected. When every person of the population will get an equal chance of being selected, then this method will eliminate all types of bias and the sample will be fair. Sampling methods. Simple random sampling. If the unit selected at each draw is not replaced into the population before the next draw, then this is known as the simple random sampling. Or you can say this sampling without replacement. Two methods of simple random sampling are commonly used: drawing lots, random number sampling. For each, make a list of all n members of the population and give each member a different number. Drawing lots. In short, you for I mean give number or name all the members. You can either give a number to all the members, different numbers to all the members, or you can write their names of the members. Then put the numbers in a container or in a head. Then select the sample of the required size at random. For each member, place a colored ball. This is a different way. For each member, place a colored ball into a container and then draw n balls out of the container at random and without replacement. The sample must be large enough to provide sufficiently accurate information about the population. This is the drawing lots method, but in short, use this method. Whenever you find a question of drawing lots in exam, write these three steps. Number or name all the members, put the numbers in a container, select the sample of the required size at random. Now this is very important. The accuracy of the information depends on the size of sample. If sample size is large, then information will be more precise. Random number tables. Random number tables consist of list of digits 0, 1, 2, 3 to 9 such that each digit has an equal chance of occurring. So for example, the probability of a number 3 is 0.1. In random number tables, the digit may appear singly or be grouped in some way. This is the method of random number table, selection of sample through random number tables. So number one, number all the members. Number two, select the sample of the required size. Number three, omit repeats and discard the numbers which are greater than the requirement. Learn these three steps because you will find this type of question in past paper. This is an extract from a set of random number tables. Now use this extract to select a random sample of 8 people from a group of 100 people. From a group of 100 people means the first person will get this number 0, 1. The last number will get this number 99, second last number in fact, and the 100% will get this number. So 1, 99, 100. So when you will select people, when you will select 8 people from a group of 100 people in this range 0, 1, 2, 0, 0, you will get this sample. Like this is the way to select the sample. You have to select 2-digit number. So the first number will be 68, then 72, 53, 81, 59, 25, 34 and 70. These are 8 people. 1, 2, 3, 4, 5, 6, 7, 8. So you just need to select a sample of 8 from this extract, but the digits should be 2-digit number. Now, this is the sample answer of part A. Now 8 people from a group of 60 people. So the first person will get this number 0, 1 and the last person will get this number 60. This is the range. So you need to select a sample of 8 in this list, in this range from this extract. So the first number is 68, but this number is greater than, it's not in this list, so you need to discard this number. 72 will be discarded as well. Now the first number will be 53. 81 will not be required because this is not in the list. The next will be 59. 25, 34, don't select 70. 54 is fine, 95 is not fine, 32 is fine, 68 is not fine, 74 is not okay, 47 and then 05. So you need to ignore the numbers which are greater than the requirement. This is a sample of size 8 of this range from this extract. This is the way to select samples in random number sampling. Well, example 2. Use the following extract from random number tables to select a random sample of 12 numbers, each to 2 decimal places. Now this is important, 2 decimal places in this range. So we have to select a sample of 12 in this range and the number should be up to 2 decimal places. So this is the way to select the sample. Select these 3 numbers and read them as 5.27. Then select these 2 numbers and read them as 4.54. Then this will be 8.06, 8.72, 5.19, 6.08, 0.00, then 2.52, then 0.99 and so on. This is the way to select the sample of size 12 in this range and up to 2 decimal places. Sample statistics. The mean and variance of the sampling distribution of means, which is x bar. Sampling distribution of means is denoted by x bar. This is the mean of sampling distribution of means and this is the variance of sampling distribution. Mean is mu and variance is sigma square over n. In population, you write this as x means population and x follows normal with mean mu and variance sigma square. You have done this in S1. Ex is mu and Vx is sigma square. This is for population. This x means population. This is very important. Capital X means population and x bar means distribution of sample means. Make sure you understand the notations well. Well, since the sampling mean, the mean of sampling distribution is mu, so x bar follows normal with mean mu and variance is sigma square over n. Ns means sample size. So this is for population and this is for distribution of sample mean. Now, this is very important. The distribution of x bar when the population of x is normal. Now, understand these things with good concentration. So, the distribution of x bar when the population of x is normal, meaning the population is normal and the distribution of x bar. So, if x follows normal, now this is very important. This is the population, normal population, because this is x and sigma square is known. Now remember this thing, when population is normal and sigma square is known, then the distribution of x bar for any sample size will always be normal. See, the distribution of x bar for all sample size is normal. This is normal, and this is also normal. You have to understand this thing well. And the condition is x is normal and sigma square is known. So when you have these two conditions, the population is normal and sigma square is known, then for any sample size, the distribution of x bar will always be normal. From the diagrams, you can see that if all samples are taken from a normal population, the sampling distribution of means is normal for any sample size. Now let me write this thing here. An important thing for you all. Population is normal and sigma square is known. So if population is normal and sigma square is known, then the distribution of x bar will always be normal for any sample size. This thing will help you to construct the confidence intervals. So make sure you remember this thing and you understand this thing well. If you want to take the screenshot of this page, you can, because this concept is very important. Example. The distribution of the random variable x is this. See, population is normal and variance is known. The mean, now this thing is very important. The mean of a random sample of size n drawn from this distribution is x bar. Find the value of n correct to two significant figures given that probability x bar greater than 28 is approximately this thing. So this question is very important. Since x is normal and sigma square is known, therefore x bar will always be normal for any sample size. And this information is given, probability x bar greater than 28 is 0.005. So you need to use this information. I mean, this will be 28 minus mean. This is the formula of z. Z is x bar minus mu over sigma over under root ns. We use this formula in distribution of sample means for this. So when you will use this entire thing, so and this entire thing is equal to this 0.005. You all know how to find inverse. When we have greater sign, we shade in this way. So this is the required area, and you can use your you have two options. You can either use calculator to get this value, or you can use table for inverse normal. This is the question of inverse normal. So this corresponding value of z of this area is 2.576. So you need to equate this thing to 2.576, and the value of n is 250. For sampling, you have to be, the background knowledge is Poisson distribution, binomial distribution, normal distribution. You must be good at all three distributions. This was case A. We have done this with an example as well. The distribution of x bar when x is normal and sigma square is known. I'm adding this thing in the heading. And sigma square is known. This is the condition. I'm writing this here. This means sigma square is known. So we have done this, that when population is normal and sigma square is known, then for any sample size, x bar will always be normal. This thing is here. Because this thing will be used in confidence interval. Case 2 or B. The distribution of x bar, sampling distribution, means of sampling distribution, when x is not normally distributed. Now this is very important. The distribution of x bar, what would be the distribution of x bar when x is not normally distributed? The x is not normally distributed means the population is not normal. So for greater sample size, now this is very important. When population is not normal, then for large samples, say n greater equal to 30, x bar is approximately normal. This fact is very important. See, x is not normal, but for large samples, x bar will approximately be normal. X bar is approximately normal. This result, this thing is known as CLT, the central limit theorem. Central limit theorem says for large samples, for large NS, x bar is approximately normal. So x bar is approximately normal. This statement means mathematically you can write x bar is normal with mean mu and variance sigma square over ns. So when let's suppose the population was Poisson. We can have three options. The population is not normal means maybe the population was Poisson, maybe the population was binomial, and maybe the population was unknown. So we have all three possibilities. What if the population was Poisson? For large samples, the distribution of x bar, the distribution of sample mean, will always be normal. So you just need to replace mu by lambda, because the mean of Poisson is lambda and variance of Poisson is also lambda. So you just need to replace this mu by lambda and sigma square by lambda. This ns should be copied. What if the population was binomial? Not normal means it could be binomial, but for large samples, this distribution of x bar will always be normal. So the mean of binomial is np and the variance of binomial is npq. So you need to replace this mu by np and this sigma square by npq. And you don't need to do continuity correction because distribution of x bar is normal. So when distribution is normal, we don't do continuity correction. So this is very important. Don't do continuity correction here. So whenever you use CLT, you never do continuity correction. And please remember this statement. For large sample size, x bar is approximately normal, and mathematically you can write this thing as x bar follows normal with mean mu variance sigma square over ns. Now the next thing, sample proportion. Sample proportion is denoted by PS. PS or P cap. This means estimated value of P. Cap means estimate. Suppose a random sample of size ns observations is taken from a population in which the proportion of success is PS and the proportion of failures is QS, and QS is 1 minus PS. If X is the number of successes in the sample, then X follows binomial. And you know, this is the way to write binomial. The random variable for the proportion of successes in the sample is X upon NS. This is the formula of proportion of success. X means requirement, frequency of requirement divided by sample size. And you can write this formula as in capital letter, we write PS, in small we write PS. And this is P cap, this is known as P cap. This means proportion of success, the estimate of P of binomial through sample. And the mean, the expectation of PS is PS, and the variance of PS is PS over Q, PS QS over NS. You need to learn these two formulas. In fact, you need to learn this formula as well. So make sure you learn three formulas. This one, and this one. When n is large, then the distribution of PS is approximately normal. And whenever we write n, this means ns, sample size. Since mean is PS, so write PS here. This is PS and this is QS over ns. And you have to do continuity correction because you are using normal approximation here. Whenever you use normal approximation, you have to do continuity correction. And this is the formula of the continuity correction, plus minus half, plus minus 1 upon 2ns. With the help of this formula, we can do the continuity correction. We can understand this through this example. An important example of proportion. It is known that 3% of frozen pies delivered to a canteen are broken. What is the probability that on a morning when 500 pies, this is the sample size, NS, are delivered, 5% or more are broken? Now this information is very important. 5% or more. How would you know this question is of sample proportion? Because the requirement is in percentage. Remember when you do binomial, when you used to do binomial in S1, the question was of this type. Find the probability that at least 5 or more are broken. You never did question of this type, 5% or more are broken, or at least 5% or more are broken. You did this type of questions. At least 5 or more are broken. So whenever we have percentage in the requirement, then the question will be of sample proportion. This is the difference, and this is the way to differentiate the questions of sample proportion and simple binomial. This thing is important. The requirement is in percentage. This will tell you that you need to use proportion, this thing. Well, number one, write this information. This is the distribution of PS. First write this, then substitute the values of PS, PS, QS and NS. And for number line, always use, for continuity correction, always use number line. Use number line to do the continuity correction. This is the best way of doing the continuity correction. So we need this probability 5% or more. We can write 5% as 0.05. So write this number here and then do this continuity correction. This formula is here, 1 upon 2 ns. You know, when we go on right side, we subtract this number from this number. This is the normal approximation. So you just need to subtract 0.001 from 0.05. When you will do this subtraction, you'll get 0.049. Now you need to find this probability. Remember, we only do continuity correction in sampling, in sample proportion questions and sampling. So this number is here, this is PS, and this is the variance, standard deviation. The number is 2.491, which is here, and this area is required, so it should be 1 minus 5, 2.491. You all know how to get this area. You have done this in normal distribution in S1. See the sketch. It's perfectly symmetrical. This shows the hard work of this student. This student is very smart and hardworking. She has made amazing notes, Alhamdulillah. May Allah Pak bless her with great success. Ameen. Unbiased estimates of population parameters. Now, this is the topic which I discussed early in this lecture, that we use sampling to estimate the values of the unknown population parameters. Take a random how to estimate the unknown values of unknown population parameters. There are two types of population parameters. Number one, point estimates. We discussed this early in this lecture. The number one is point estimates and number two is interval estimates. We have three formulas in point estimates. Number one, we estimate the value of binomial, the proportion of P, the probability of success of binomial. So when the P of binomial is unknown, then we use this formula, the formula of sample proportion, to estimate the value of P of binomial. So if P of binomial is unknown, then we use this thing. We use the formula of sample proportion, which is x upon ns. We just did this. And we equate PS to P cap. P cap means the population of success, the estimate of the population of success. See, this P means probability of success of binomial. When this is unknown, then we estimate its value through sample proportion. This PS means sample proportion, and this will be equal to, this will be P cap. P cap means the estimate of this P. So I'm writing this here. When P is unknown, then use this P cap, which is PS and x upon ns. Whenever they say estimate the value of population of proportion of success, then always use this formula. Number two, when mu of normal distribution is unknown, the best unbiased estimate of mu means the population mean. When population mean is unknown, then we use mu cap. Mu cap means estimate of the population mean, and this is x bar, the sample mean. So what we do, we take a sample from the population and we find the mean of that sample, and that mean will be mu cap, means the estimate of population mean. So when mu is unknown, mu means population mean is unknown, we estimate its value through sample mean. Now, the next thing is the best unbiased estimate of sigma square. Sigma square means the population variance, and the best estimate, unbiased estimate, is sigma cap square. This means the estimated variance, population variance. Let me check if I have a table so that you can understand these notations well. I think the table is not here, so let me write the notations here. Yeah. Wait a minute. See, number one, population. Number two, samples. For population, mean, variance, and then estimates of population parameters, and this is sample. You just need to learn these notations. For population mean, we use mu, and for estimates of population mean, we use mu cap. For sample mean, we use x bar. For population variance, we use sigma cap square. The estimates of population variance is denoted by sigma cap square. This is sigma square and this is sigma cap square. And sample variance is denoted by s square. And the formula of sample variance is sigma x square over ns minus x bar square. And the other formula of sample variance is x minus bar square whole square over ns. So we were here, we were discussing the point estimate. So when the p of binomial is unknown, we estimate its value. We estimate its value through the sample proportion. When mu of normal distribution is unknown, we estimate its value through sample mean, and we estimate the value of sigma square with the help of this formula. Sigma square means population variance. When it is unknown, we estimate the value of sigma square through sigma cap square, and this is the formula of sigma cap square. This is sample variance. This means s square. You can also use this formula here. Since we have two formulas of s square, see, we have two formulas, this and this, so we can use this formula here as well. ns minus 1 sigma x minus x bar whole square over ns. So we have two formulas for sigma cap square. In short, you can learn sigma cap square as ns minus 1 times s square. This means sample variance. You have to learn this formula, and these two formulas. This is the point estimates. And these notations are very important. Make sure you learn these notations well. You understand well and then learn these notations. Now, this is the most important part of sampling and estimation, the interval estimates. They are commonly known as confidence intervals. Another way of using a sample value to give a good idea of an unknown population parameter is to construct an interval known as confidence interval, CI. These are the limits of confidence interval. This is the lower limit and this is the upper limit. These have a specified probability of including the parameter. For example, we have this. This means the probability that this interval includes mu is 0.95. You can say there are 95% chance that your mu lies in this interval and 5% chance that mu does not lie in this interval. Make sure you understand this thing. This thing means you are 95% sure that your mu lies in this interval and you are 5% unsure that mu lies in this interval. And this is the formula of confidence interval. This is sample mean. So in this formula, this means sample mean. This is the normal distribution variable, standard normal variable, sigma and ns. We will discuss this formula in detail later in this lecture. You must answer before constructing confidence interval. Now this is very important. Before constructing the confidence interval, you must know three things. Number one, the name of the population. Whenever you are going to construct the confidence interval, you must know the name of the population, whether the population is normal or not normal. Number two, you must know about the variance, whether the variance is known or unknown. And number three, you must know the sample size. So three things are very important. I'm writing these three things here. Number one, for confidence intervals, in fact, we must know three things. Number one, name of the population. Number two, we must know the variance, whether it is known or unknown. And number three, we must know about the sample size, whether it's large or small. So, and you will find these three things in the question. When you go through the question carefully, you will get all the answers of all these three things. So before constructing the confidence interval, we must know about these three things: name of the population, about variance, and sample size. So this is the case one. Case one is confidence interval. Now this is very important. Pay your full attention here. Now we are working for confidence interval of mu. Now confidence interval for mu, the population mean. Number one, the given information is the population is normal, variance is known, and any sample size. Now two things. See, when population is normal and variance is given, then the sample size is irrelevant. I mean, whether the sample is small or large, it does not matter. Make sure if two informations are given, if the population is normal, if the variance is known, then sample size is not important. You can, any sample size is fine. Then distribution of x bar will be normal. Now understand this thing in this way. These three informations, especially these two informations, means the population is normal. Mu sigma square. And sigma square is known. We have two conditions here. Number one, population is normal, and number two, sigma square is known. Then for any sample size, then for any ns, the distribution of x bar will always be normal. I hope you all have understood this thing. These two informations means the population is normal and sigma square is known. When we have these two informations, then sample size is irrelevant. Whether the size is small or large, no problem. The distribution of x bar will always be normal. We did this thing here. On page 10. See, I told you when x is normal and sigma square is known, then x bar will always be normal for any sample size. And I told you we will use this information in confidence interval. Now we are using this information in confidence interval here. So when we have this thing, then this is the formula of the confidence interval. This is small x. X bar, this means sample mean. And this means the value of z from normal distribution table or calculator. This is the standard deviation. If you will take square root of this quantity, you will get the standard deviation. And this is here. So we use this formula to get the confidence interval or to find the confidence interval for this information. And this is the width of confidence interval. When you multiply this quantity by 2, you'll get the width. Now this is an important example to understand this concept and to understand how to construct confidence interval for this information. So much hard work has been done onto this PDF, and this student did amazing work. The mass of vitamin E in a capsule manufactured by a certain drug company is normally distributed. Now the first information, remember I told you, you will find all these three information in the question. This one, and this one. Name of the population, about variance, whether it is known or unknown, and size of sample. You will always find these three information in all types of questions of sampling and estimation of confidence interval. Now it's the first information, normally distributed. You have known, now you have understand that this distribution is normal. You know the name of the distribution now. With standard deviation means variance of the population is known, it's 0.042. So we have all very important information. The distribution is normal and standard deviation is known. A random sample of size 5. I told you when population is normal and variance is known, then sample size is irrelevant. Whether the n is large or small, it's not important. You can always use this formula for confidence interval. So the mass of vitamin E in a capsule manufactured by a certain drug company is normally distributed with known variance or standard deviation. A random sample of size 5 capsule was analyzed and the mean, this is the sample mean, x bar, mean mass, X bar of vitamin E was found to be 5.12. Make sure you understand the information of the question very well. Calculate a symmetric 95% confidence interval for the population mean mass of vitamin E per capsule. Give the values of and three significant figures, no problem. So, how will you construct this interval? This is so simple. We have this information. The population is normal and sigma square is known. Sigma known means sigma square is known. And for any sample size, we always use the distribution of X bar is normal. I told you when population is normal and sigma square is known, then the distribution of X bar is always normal for all sample size. Well, 95%, you will use this formula for confidence interval. And in this formula, you can get the value of Z. Let me write this formula here. I'm using this formula here. X bar plus minus Z sigma over NS. We are using this formula here, and we have to construct 95% confidence interval. 95% confidence interval means this thing. This means 95%. This area is 95%. So this and this will be 2.5% each. Therefore, this total area I'm sorry. Therefore, this total area, this area will be 97.5%. And you can get the corresponding value of this area either by using your calculator, through your calculator, or from table. This value is 1.96. And this value is here. I told you we write the value of Z from table or calculator. We found this 1.96 through this way. So whenever it says 95%, then you have equal areas on these two sides. So get this total area and then use your calculator or table to get this value of Z. So X bar plus minus Z sigma over NS, we have X bar, it is 5.12. See, this is X bar, it's 5.12, Z is here, it's 1.96, sigma is given, and 5. So when you will calculate this thing, one with number one with plus sign and the number two with negative sign, you'll get these two values. And this is the confidence interval. This confidence interval means you are 95% sure that your population mean mu lies in this interval. This mu lies here, you are 95% sure. If the question is estimate mu, so you can easily estimate mu by taking the average of this interval. This is the advantage of constructing the confidence interval. We can find mu by taking the average of confidence interval. This is the way to get mu. And this is the main purpose of sampling and estimation. See, we have found mu. We have estimated mu. So this was case 1. And case 1 was, let me give you a short review regarding the case 1, then we'll do case 2. In case 1, the population was normal and population variance was known. So when population is normal and variance is known, then for any sample size, X bar will always be normal. And this is the formula of confidence interval, and this is the width of the confidence interval. Now, this is very important. We have done CLT before, and when population is non-normal. Now, when population is non-normal and sigma square is known for large samples, now this is very important. The sample size must be large, and this is in S2 syllabus. When population is non-normal, they will always give you large sample, 30 or more, of size 30 or more in fact. Then this is the application of CLT. This large sample means the application of CLT. Whenever n is more than 30, then we can use at least 30, we can use CLT. When population is unknown and n is greater or equal to 30, we can always use CLT. Because the statement of CLT is for large sample size, the distribution of x bar is normal. This means is approximately normal. Well, this is the formula of the confidence interval for this case. I'm writing the formula of confidence interval here. Confidence interval for mu for this case. It is x bar plus minus z sigma over ns. You should learn this formula for this case. I'm sorry. Same thing is here, but they basically they made the formula for 95%. You don't need to learn this formula. You can only learn, you should learn this formula. When you put 95% value, it will be 1.96. The formula will become like this. So to make the thing simple, I'm erasing, it's fine. This formula is also fine. But I'm writing this formula here as well. Or confidence interval for mu. For this case, the formula is x bar plus minus z sigma over ns. And the width of confidence interval will be twice of this thing. Please learn these two formulas for this case. They are similar to this one. They are exactly this one. Because of CLT, the formulas are same. So if you have learned these formulas, you can use these formulas for this case as well. When population is non-normal, sigma square is known for large sample size according to CLT. X bar is normal, so we have this formula. Example. An important example. The heights of men in a particular district are distributed. See, the name of distribution is not given. The distribution is unknown. The population is unknown. This is of this case. Not population is non-normal. Non-normal means it's unknown. It's not mentioned whether the population is normal or non-normal. So it's not normal. This will become case 2. When sigma square is known and population is unknown, then the case is case 2. Standard deviation is sigma on the basis of the results obtained from a random sample of 100 men. This is the sample size from the district. The 95% confidence interval for mu was calculated and found to be this. This is the confidence interval for mu. Now calculate the value of the sample mean. Confidence interval is given. We need x bar, number 1. Number 2, we need sigma. And number 3, we have to construct the 90% confidence interval for mu. Now, since sample size is large, therefore, according to CLT, x bar is normal. approximately normal in fact, and this is and the value of z for 95% is 1.96. So in confidence interval formula you need to write 1.96 here. We are using this formula here, x bar plus minus z sigma over ns, and the value of z is 1.96 for 95%. Well, you can form two equations, one with plus sign. X bar plus 1.96 sigma over ns will be 179.18, this thing, and with negative sign x bar minus the entire thing will be 177.22. By solving these two equations simultaneously, we can get the value of x bar and sigma. Now 90% confidence interval means 90% confidence interval means this area, the area on the left side, I'm sorry, this is 90%, so this should be 90 and these both should be 5% each. So this total area will be 95%, this one. And you should use your calculator or table to get the value, corresponding value of z of this area. The value of z is 1.645. Now you just need to use this formula of confidence interval. X bar plus minus z sigma over ns here to get the confidence interval, 90% confidence interval from you. So x bar is 178.2, sigma is 5, sample size is 10, and z is 1.645. This is the confidence interval for mu. If you want to check the solution of this example again, you can. You can even take the screenshot if you want. This is the last confidence interval for mu, and in this the population is maybe normal or non-normal. This is for both, but the most important thing is sigma square is unknown and sample size is large. So when population is either normal or non-normal, variance is unknown and sample size is large. So according to large sample size, the distribution of x bar is, according to CLT, the distribution of x bar is normal. This is the application of CLT. And since sigma square is unknown, therefore we will use sigma cap square. This is the formula of sigma cap square, and this is the formula of the confidence interval. The same formula which we use in the previous two cases. In the previous two cases, we use this formula x bar plus minus z sigma over ns, but here we have to just make this change, sigma cap. Instead of using sigma, we have to use sigma cap. See, we use sigma here, but here we have to use sigma cap. Just this thing is different and the rest is same. And the width of the confidence interval will be 2 times z sigma cap over ns, meaning twice of this thing. Example: the fuel consumption of new model of car is being tested. In one trial, 50 cars, this is the sample size, chosen at random, and the name of the population is not given, were driven under identical conditions, and the distances x kilometer covered on 1 liter of petrol were recorded. The results gave the following totals. See, name of population is not given, sigma square is unknown, so this is the case C, and sample size is large, so according to CLT, x bar is normal. With the help of these two results, we can calculate x bar, the sample mean, and the sigma cap square. the unbiased estimate of population variance. So these are the values of these quantities. Now we have to form 95% confidence interval. So we are using this formula here, x bar plus minus z sigma cap over ns here. And since it's 95%, to the corresponding value of z is 1.96, we have these informations. Make sure you write the large value of sigma. This is very important. Write the whole value of sigma here. So I'm writing dot dot here. You should do this calculation yourself and write the whole value sigma here. And this is the confidence interval of mu. This question is very important, because in this question we first found x bar, then we found sigma cap square, and then we use this formula for the confidence interval. Well, this is the last thing of this lecture, the last concept, I guess. Confidence intervals for the population proportion PS. We have done this earlier in this lecture. This is the, for large sample size, PS is approximately normal with mean PS, and variance is this. The confidence interval formula is this of PS. This is the formula of PS. And the width of this PS will be, just need to learn this formula. It should be 2Z PS QS NS. So just learn these two formulas, and this one is as well. Now, example. A manufacturer wants to assesses the proportion. Now this is very important. How would you know? You have to use this formula because it's given proportion. This means PS. Proportion of defective items in a large batch produced by a particular machine. He tests a random sample of 300 sample size. 45 items are defective, so you can get PS easily. It should be 45 over 300. It's here. Now we have to construct the confidence interval for sample proportion 95%. So this is the formula we are using here. This value of z is 1.96, and this is the confidence interval for PS. And you can estimate PS by taking the average of these two values of confidence interval. Now this is the summary. This student has done an amazing work, a brilliant work. This shows how this student is an outstanding student. Summary. So this was case A. We did this thing in case A, case B, case C, and this is the sample proportion thing. So this is the confidence interval formula for case A. We don't use CLT here. We use CLT here and here. And I told you can learn the formula like in this way as well. So instead of learning this formula, you can use this formula. This is 95% in fact, so the formula is according to 95%. So you can learn these formulas in this way as well. So for case A, the formula should be, I'm writing this with different pen, red pen. Let me first separate these three cases. Now I'm writing the formulas here. So x bar plus minus z sigma over ns. This is the formula of confidence interval for case A. This is x bar plus minus z sigma over ns, because this is according to CLT. and this is x bar plus minus sigma cap, sorry, z, then sigma cap over ns. And the formula of ps is, it is ps plus minus z under root ps qs ns, and you all know how to get the width. So for width we multiply this thing or this thing by 2. I'm writing width for the last case, and for the width of this proportion thing, the formula will be 2z ps qs ns. If you need this PDF, then you can WhatsApp me on this number, and I'll give you the PDF of this chapter. The number is here. It's 0. Let me write the number here. Okay, I write the number at the end over here. 0336 457 11 12. Well, this is all from this lecture. I hope this lecture will help you to understand this chapter well. An important advice for me and for everyone: we should be good to others. Allah Hafiz.